Hello, Psychology of Illusion class. Today we're going to be talking about visual illusions of space, and this is going to be the first part of your mini lecture for visual illusions of space. We'll be talking about depth and size, as well as shape and orientation. As you can see, a few very simple illusions up there, the Devil's Triangle and that shelf, which is one shelf on the left and two shelves on the right. Part of what you're seeing there is how our mind constructs the spatial relationships with all these edges is an illusion. All right, I'm going to be showing a few illusions from M.C. Escher, one of my favorite artists. And this illusion is, I believe, upstairs and downstairs. I think the name of this drawing is, and it just shows how our mind and eyes look around this scene and decide on the spatial relationships, decide on space, which end is up, as you put together these edges. So for example, if you're paying attention to this person here, you see these as going upstairs. These are upstairs, and the ground is that way. Whereas if you're paying attention to this person, oh, all of a sudden he's going downstairs that way, and the spatial orientation is totally different. Part of what's happening here is as you pay attention to each of these edges, you're deciding which edge is a stair and which direction it's going. We'll come back to that later. Here's another M.C. Escher painting, drawing. And this is called Ascending, Descending. And what you can see is that these stairs somehow all go up. And you can travel in one direction, going around this way, and going up and up and up and up, never stopping. And again, part of what's happening here is the way that our eyes and visual system construct the spatial geometry of this scene leads to this illusion. As a little bit of fun, someone made this in Lego, and you can see it's a Lego version of the Ascending, Descending. So you can make this in real life. The trick here is that it's from a particular point of view, that this image that you have of this 3D Lego structure is a particular image. Here's another view of that same Lego structure. You can see here that they do not connect. So that those Lego people and these Lego people are actually, there's a big gap. But doesn't appear to be a gap. Oops. Doesn't appear to be a gap here, but there is. Another fun illusion. This is called the Shepherd's Table illusion. Shepherd's Table, both of those tabletops are the same size and shape. We can see this in PowerPoint. If I move this over and rotate the tabletop, it fits perfectly on top of the other one. So what this is exposing is the way that we see the shape of these tabletops depends on how we see the table legs and depends on how we see the depth in this scene. Doesn't exactly seem like a scene, but we're so used to taking these two-dimensional images and transforming them into 3D scenes that we can't help but see this as a three-dimensional scene. Here you could also take a view at the other YouTube video of my own Shepherd's Table that my dad and I designed. Okay, so again, what we're going to keep coming back to in this course is a theme that perception is so familiar and easy. We open our eyes and the world is just there. We open our eyes to see a building and the building kind of appears in our head. It appears as a vision, a representation that we have. So, but as we'll see in this class, remember our themes, right? Illusions are informative, illusions are everywhere, and illusions show how our visual system, how our systems are adaptive. In this case, we're going to see how our eyes have adapted to seeing the world around us. Okay, perception is hard. In fact, perception is very complex, and it's a very difficult task. What do I mean by it being a difficult task? Visual perception is something that is very difficult for your brain to do. Just because it doesn't feel difficult doesn't mean that the problem itself isn't a very hard problem. So here's the basic idea of the problem of perception. So the environment is 3 dimensions. The environment is 3-dimensional. The world out there has 3-dimensional objects. The ground the ground might be flat, but it has hills and bumps and waves. The world is 3D. Also, the world has constant properties. The world has objects that have the same size no matter where you move them, objects that have the same shape, and then objects have the same color no matter what kind of light is shining on them. So objects have a surface qualities that we might be interested in. So that book behind me is orange, right? That umbrella behind me is red. And those are constant properties of the world, constant 3D properties of size and shape. And then the world reflects wavelengths, constant wavelengths, even though we move around. So here's where the problem comes in. Our retinal images are 2 dimensions, right? So the light that goes in the world gets into my eye, it casts a 2-dimensional image on the back of my retina. Those images, as I'm moving around, as I look out the window, as I look into the rest of my office, those images have varying properties, meaning that if I take, let's say, take my pen, and you can kind of see this as an example, that the pen on the video, right, it changes size. The image of the pen changes size, even if the pen itself is not changing size, right? So the pen changes size. I can put the pen, let's see, in the light, and now it's going to be, let me see, how do I do this? There we go. So as it's in the light, now it's not black, right? The pen is reflecting different wavelengths. So these varying properties of size and shape, right? If I point the pen like this, now it's a totally different shape. That's what you're getting on the retinal image, and it's kind of convenient we have the video, right? That the video image that you're seeing also has varying properties of size, shape, and color. My hand, right? As it gets closer, it gets bigger, it's farther, and now you have a different view of my hand, right? So the big problem is, how do we take the information that we have, which is just the retinal images? That's what we have, that's what our brain gets, and what we need to do is reconstruct the environment from our retinal images. And we do that enormously successfully, meaning our visual experience of the world is that the world has constant properties of size and shape and color, right? So the objects that we see, even if our images of the objects are changing, we see those as constant size, shape, and color. So our perception has those problems to solve. So what does this mean? This means that our perception of the world is constructed, meaning we take our visual images from our retinas and construct a 3D world. We imagine a 3D world from the data that we get from the light on our eyes. But it's not just the data that we get from the light on our eyes. We need to add knowledge that we have about what objects are out there, assumptions and expectations of what we think should be there, and we have to do this to reconstruct the environment when we're only given a retinal image. We're basically given 2 video images. It's not really video, but it's a good metaphor, right? We're given 2 images in the back of our eyes, and we have to decide what world corresponds to those flat images. Okay, so space is an illusion. This means that space, what I mean by that is that space is kind of a figment of our imagination, right? A figment of our visual system, that the retinal image, the data we actually have, is limited and flat, but our perception of the world is rich in 3D. We create the world from our retinal images. You can kind of think of it like we have just shadows, projections on the back of our eyes, and we think what world corresponds to those shadows that we have. Here we have an artist. This is an artist who's made shadows of a motorcycle here and shadow of a ship. And you can see, you might imagine, oh, those shadows correspond to those objects, this object of a motorcycle and an object of a ship. As it turns out, that artist has created those shadows with light from a particular perspective, and that is all silver cutlery. So it's forks and spoons and knives that he has glued together to create a shadow of a ship and a motorcycle. Okay, so that's I think a good introduction of the space is an illusion idea. The next video, I'm going to explain what the particular trade-offs are and how we solve those trade-offs. So space is an illusion. How do we construct space? How do we solve the problems that we have from our retinal image? Thanks for your attention.